It's evaluating the trigonometric Fourier series representation for this waveform, half wave rectified sine waveform with it's a 0 extending to pi, and this is the waveform 2 pi. Now, important point over here is, now this is the complete time period, one cycle, and in between we have pi by 2. So this has to be noted. T value is pi over here, and what will be x of t then? Now it's a sine wave starting from t equal to 0, so x of t in general a sine omega naught t, and omega naught in general we have 2 pi f naught still, which is 2 pi by t, and the time period for complete time period for one cycle is pi, so 2 pi by pi, and cancelling these two, what do we have? The omega naught value is 2, and so x of t takes the form, x of t will take the form a sine 2t. Now we will make use of this x of t to evaluate the trigonometric Fourier series representation for this half wave rectified sine wave. Note it's pi extending from pi to pi, etc. like that. And that general expression for trigonometric Fourier series is x of t is a naught plus summation n equal to 1 to infinity a n cos n omega naught t plus bn sine n omega naught t. Now what to do with this one? Put it inside the bracket to say that the summation is for both the terms. Now what we have to do? We have to evaluate a naught value, a1, a2, a3, a4, etc. up to infinity, b1, b2, b3, b4, etc. up to infinity. We'll have to find out the coefficient values and then come back to this one and then open the series for n equal to 1, 2, 3, 4, 5, 6, etc. to infinity. That's what we have to do. We have to compute a naught, an, bn in general expressions, then a1, a2, a3, a4 to infinity, and all that. Alright, so this is the expression. We have to come back to this one. Now, how about a naught? Calculating a naught, that general expression is what is 1 by t integral t naught to t naught plus t x of t dt is the general expression which we make use to calculate a naught in any trigonometric Fourier series, right? So now for this waveform, t is pi and integration is from 0 to pi by 2. X of t is a sine 2t dt. Expanding this one, a by pi as it is, integral sine theta minus cos theta, isn't it? So minus cos 2t by 2, and the limits are 0 to pi by 2. Alright, so a by pi as it is. Plugging in the upper and lower limits, we have 2 over here, minus cos 2, and pi by 2 comes in t, so it's a pi by 2, minus lower limit, minus, we already have a minus, that will be plus cos 0 over here, this becomes 0, cos 0, it's a 1. Alright, so let's check if a by pi. So guys, in your presence, what is that? What do we have? Yeah, this 2 gets cancelled, so minus, we have minus cos pi plus 1, what it is, minus cos pi plus 1. Its value is minus cos pi. Calculated in radians, minus cos pi plus 1, it's a 2. 2 by 2, it's a 1. So we have 1 over here. Finally, it's a by pi. Alright. In the sense, a naught value is found out to be a naught. I'm writing over here. A naught value is found out to be a by pi. How? This value will tend to 2. 2 by 2, 1. So this is the value. It doesn't become 0, but we have a value for this one. Now, a naught to be found out to be a by pi. The next coefficient is an, making use of the same x of t. Making use of the same x of t. Expression for an is an is generally 2 by t integral t naught to t naught plus t x of t cos n omega naught t dt. The general expression for to calculate an, the coefficient an. And plugging in our values from the waveform which is given. an is 2 by t is pi once again, pi. Integration is from 0 to pi by 2. X of t is a sine 2t cos n, okay. Omega naught is 2 and t dt. Guys, if you watch carefully, we have a trigonometric identity in this expression. It's a 2. Now this one, it's a now this one, 2 nt is b. Now we have 2 times sine a cos b trigonometric identity in this expression. Alright, so this takes up the form. If that is the case, if that is the case, an will be equal to 2 by 2a. No, reducing that to its trigonometric identity, a by pi, 2 disappears along with sine a cos b. Alright, it's a integration is from 0 to pi by 2, and sine a cos b, sine a plus b plus sine a minus b, isn't it? So the first term will be sine a plus b, a plus b. So in that case, you can take 2 and t as common, 1 plus n over here, plus sine a minus b, isn't it? Sine a minus b. So 2t minus 2nt, 2t as common, 1 from here minus n from here. Now this is what we have, the trigonometric identity over here, and it's a dt. It's a dt. 2 disappears along with this one. Yeah, there we are. This is how the trigonometric conversion looks like. And so a by pi, and guys, applying the integration over here, integration is for both the terms, okay. Integral this plus integral this. So integral sine theta d theta, it's a minus cos, isn't it? So minus cos 2 into 1 plus n t by 2 times 1 plus n plus for this. Alright, integral this one, so minus cos 2 times 1 minus n into t by 2 into 1 minus n, that's it. Alright, minus for this one. And the limits of integrations are, let me plug in over here, the limits of integrations being 0 to pi by 2. If you watch carefully, something else can be taken out as common here. This 2 from here, this 2 from here can be pulled out at this point. And let's avoid that confusion, like multiplication, okay. Yeah, this is the one. Alright, an by, an equal to an, coefficient an is equal to a by 2 pi. Plugging in the limits, pi by 2, 0 to pi by 2 for this one. Let's see what happens. Minus cos 2 into 1 plus n, t, in the place of t we have pi by 2 by 1 plus n for the first upper limit. Alright, minus lower limit, isn't it? Minus, and we already have this minus, that becomes plus, and cos 0 comes over here at 0, this becomes 0, cos 0, it's a 1 by 1 plus n for these two. Alright, now this for these two limits, minus cos 2 into 1 minus n, and in the place of t we have pi by 2 by 1 minus n. 2 has come already out from here. Alright, and minus lower limit, minus lower limit. This has already negative, so this will be positive, and this comes over here making cos 0, that's 1 by 1 minus n. Alright, so even there is a small transformation over here, there is small reduction. This 2 and this 2, this 2 and this 2 gets cancelled, that doesn't exist anymore. I'm erasing this 2, alright, to avoid confusion. You make a mark of this one, this 2 and this 2, we don't have it anymore. And if this is the case, guys, making use of this expression, we can calculate a1, a2, a3, a4, a5 up to infinity. But hold on, we have a problem with n equal to 1. We have a problem when we calculate for a1, n equal to 1, a1, we have a problem over here. Come, focus on the denominator. 1 plus 1, that 2, it's not a problem. 1 plus 1, it's not a problem. Here comes the problem. 1 minus n equal to 1, 1 minus 1, 0, and this becomes infinity. 1 minus 1 becomes 0, this becomes infinity. A1, which is a part of trigonometric Fourier series, is infinity, and the entire series will become infinity. That doesn't happen. In the sense, A1 is not calculated making use of this expression. We have to go for another approach, making use of some other trigonometric identity. We'll have to evaluate for A1. Alright, it doesn't tend to infinity. No, we have another approach. So, A2, A3, A4, etc., A4, etc., up to infinity, making use of this expression. Alright, so if let's see what happens with the alright, let me check if n equal to 2, which gives A2. Let's see what happens with that one, A2. In the sense, A by 2 pi as it is, and over here minus cos 1 plus 2. It's a 3 pi by 3 plus 1 by 3 minus cos here 1 minus 2 minus pi, minus 1 and minus pi, by 1 minus 2 minus 1 plus 1 by 1 minus n minus n. Alright, let's see if what this results to. So making use of a calculator. Once again reminding you, put that calculator in radians mode and then calculate these values. Minus cos, it's a 3 pi. Alright, 3 pi by 3 plus 1 by 3 minus, so what do we have? Cos minus pi by minus 1 plus 1 by minus 1. Alright, so it's a from here to this point, it's a continuation to this one. A by 2 pi, it's okay, but from this its value is minus into minus 4 by 3, it's a 2, so it's a minus 2a by 3 pi. What value is this? It's a A2 value. A1 will be computed in another approach. A2, it's found out to be minus 2a by 3 pi. Alright, that's for A2. N equal to 3 gives A3. N equal to 3. N equal to 3 gives A3, and A3 once again, A3 is 2, no, A by 2 pi, and inside the bracket what do we have? N equal to 3, 1 plus 3, so 4 minus cos 4 pi plus 1 by 1 plus 3, so 4 minus cos 1 minus 3 minus 2 pi by minus 2 plus 1 by 1 minus 3 minus 2. Let's check if what happens with this value. Alright, so for the calculator, making use of calculator, minus cos 4 pi by 4, alright, plus 1 by 4 minus it's a cos minus 2 pi by minus 2 plus 1 by minus 2. What are we calculating for? So guys, it's a 0. From here to here it's a 0. 0 into this, it's a 0. In the sense, A3 equal to 0. Alright, so A3 found out to be 0. Now, n equal to 4. N equal to 4. N equal to 4, we go for A4, and which is A by 2 pi. Okay, A by 2 pi. And what do we have? Minus cos n equal to 4. So 5 pi by 5 plus 1 by 5 minus cos 4, 1 minus 4 minus 3 pi by minus 3 plus 1 by 1 minus 4 minus 3. Let's check if what this yields. Alright, it's a minus cos 5 pi by 5 plus 1 by 5 minus cos minus 3 pi by minus 3 plus 1 by minus 3. Guys, it's here a by 2 pi into this one. This value is found out to be minus 4 by 15, 2, and finally minus 2a by 15 pi. Alright. Homework. What's that coefficient? We went for a4 equal to minus 2a by 15 pi. So this is how we calculate each and every coefficient individually. And now it's time to a5, n equal to 5. In the sense we go for a5. Once again a by 2 pi. So now this one will be n equal to 5 minus cos 5 plus 1, 6 pi by 6 plus 1 by 6 minus cos 1 minus 5 minus 4 pi by minus 4 plus 1 by 1 minus 5, it's a minus 4. Alright. So once again minus cos 6 pi by 6 plus 1 by 6 minus cos minus 4 pi by minus 4 plus 1 by minus 4. It's a 0 again. This one, this entire thing is a 0. In the sense, 0 into this one, it's a 0. And a5, it's a 0. Alright. So, n equal to 6 this time. N equal to 6. N equal to 6 gives us a6, which is equal to a by 2 pi and minus cos 1 plus 6, 7 pi by 7 pi, 7 plus 1 by 7 minus cos 1 minus 6, isn't it? So minus 5 pi by minus 5 plus 1 by minus 5. What next then? It's minus cos 7 pi minus 7 plus 1 by 7 minus cos minus 5 pi by minus 5 plus 1 by minus 5. A6, isn't it? Now this results to a by 2 pi into, now the entire value is minus 4 by 35, 2 times minus 2a by 35 pi. Alright, so a6, what did we calculate just now? A6 is minus 2a by 35 pi. Alright, so this is how. By now you should have understood some pattern. Even we have values, 2, 4, 6 we have values, and odd we have zeros. Alright, so this is our this one. For A1 we have to have another approach. What's that? I don't remember. An is found is 2 by t integral t naught to t naught plus t x of t is multiplied with cos n omega naught t dt, isn't it? And A1 will be 2t is pi from a waveform. Integration is from 0 to pi by 2. X of t is a sine 2t cos n equal to 1. So this will be 1. Omega naught is 2t dt. If you watch carefully, we have come across another trigonometric identity. 2 sine a cos a. Now a is our 2t. A is our 2t. Sine a cos a, and we don't need this anymore. We have calculated enough of coefficients to put it in the series. Alright. If you are interested, go for that one. Like A7, A8, each and every. If you want your answer to be very big, go. A1. What's that? Sine. Which identity? 2 sine a cos a. 2 sine a cos a. It's sine 2a. So A1 will be 2 disappears. which will be included over here, a by pi, a1, a by pi, integral 0 to pi by 2, integral 0 to pi by 2, sine 2a, 2a, and a is our 2t, so this will be 4t. Alright, this should be our 4t dt, and opening up the integration, a by pi, sine is minus cos 4t by 4, 4t by 4, and the limits are 0 to pi by 2, and opening that one, a by pi, we are not touching it, minus by 4, okay, cos what, 4 into pi by 2 minus 1, this one over here, and cos 0 is a 1. Guys, this is what it happened, this is what, no, where did I go wrong? By it's a sine 2t, and sine 2t, alright, sine 2t, and 4 over here, it's this one, so this one, yeah, this is, so what do we have over here? It's a, did I go wrong? I don't think so, minus cos pi, it should be plus 1, alright, minus lower limit, this has already a negative, so that one plus 1, so 2, now this one, it's a by pi, alright, a1, a by pi, a1 is, no guys, let me check, a by pi, and minus cos, what did we have here? It's a 4 by 2, isn't it? 4 by 2, and so it's a 2 pi, yeah, what did we have? 4 from here, and t pi by 2, and so here it's a 2 cos 2 pi plus 1, minus cos 2 pi plus 1, let's check, minus cos, I'm sorry for the delay, 2 pi plus 1, guys, it's a 0, entire thing is 0, a1 is 0, alright, in that way a1 is 0, here check, minus cos 2 pi, somehow it's 0, and this a1 is found out to be 0. If you see the pattern for the negative values, a3 0, a5 0 done in like with this equation, and a1 also found out to be 0, alright, so this is how we show that it's not infinite but it's a 0. And what about bn? Bn is 2 by t integral t0 to t0 plus t x of t multiplied with sine n omega naught t dt. In general, like this is in general, and from the waveform we have 2 by pi integral 0 to pi by 2, x of t is a sine 2t sine n omega naught t dt. Watch carefully guys, watch carefully here. B2, 3, 4, 5 tends to 0. We can calculate only for B1. B1 in the sense, now n equal to 1, we have only this, alright, and omega naught is 2 again. So here, what do we have? We have this 2, yeah, 2a by pi integral 0 to pi by 2 sine square 2t dt. If you watch carefully, yeah, we have a trigonometric identity over here. Sine square theta is 1 minus cos 2 theta by 2, isn't it? And our theta is this one. So 2a by pi integral 0 to pi by 2 1 minus cos 2 this one, in the sense 40 40 by 2, and here this 2 and this 2 gets cancelled, and so we don't have this anymore. We don't have this anymore. And dt for this one. This is how we calculate for guys B2, B3, B4, B5. The video is being lengthy. I'm delayed. So calculating only for B1. Alright. So B1, that will be equal to a by pi integral 0 to pi by, guys, direct integration. Alright. So go for a bigger bracket. So go for a bigger bracket over here. Integral 1 dt. It's a pi by 2 minus 0 for this one, minus integral cos, it's a sine, sine 40 by 4 with the limits 0 to pi by 2. Alright, so a by pi, am I going wrong? No, pi by 2 minus 0 from the first term, minus of 4 sine 4, in the place of t we have pi by 2, minus sine 0, it's a 0. Alright, so even here it's a 2, 4 by 2, it's a 2, sine 2 pi, sine pi 2 pi 3 pi, it's a 0, it's a 0, this entire thing will be 0. Alright, so finally we have a by pi into pi by 2 into pi by 2, pi by gets cancelled, a by 2, b1 is found out to be a by 2. Alright, so b2, b3, b4 are all zeros. Try to evaluate making use of that way. We went for an, bn, do it the same simplification. You come across trigonometric identity, and here x of t coming back, a naught plus summation n equal to 1 to infinity an cos n omega naught t plus bn sine n omega naught t. We got to expand this summation over here, like what? X of t will be a naught plus a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught t plus a4 cos 4 omega naught t plus a5 cos 5 omega naught t plus a6 cos 6 omega naught t plus etc. to infinity plus b1 sine omega naught t plus b2 sine 2 omega naught t plus etc. to infinity. Alright, and found out a1 is 0, a3 is 0. In the sense we don't have this a1 coefficient in the final series, a1 doesn't exist, a3 also doesn't exist, a5 also doesn't exist. Only this remains in the these are the leftovers in the final series for the trigonometric Fourier series representation. In the sense x of t will be a naught is found out to be a by pi, alright, plus a2 is minus 2a by 3 pi cos 2 omega naught t, alright, plus a4 is minus 2a by 15 pi cos 4 omega naught t, alright, plus a6 is minus 2a by 35 pi cos 6 omega naught t plus to infinity plus b1 a by 2 sine omega naught t. That's it. We don't have any b2, b3, b4. So this is the final Fourier series for the given half-wave rectified sine wave. That's it.